Tell me. I don't mind, even it's broken or whatever it is.
Uh, Buoyancy is when an object is when an object floats on top of the liquid due to a force, upward force, then it's called buoyancy.
Repeat it. I think it's not clear yet.
Like when an object is floats on the water, and it's the water then gives an upward force, then it is called buoyancy.
Right. This is being termed as buoyancy. So this is buoyancy is the weightlessness of liquid. Okay. We studied in gravity about weightlessness.
Yeah.
So it is the weightlessness in liquid. Weightlessness in liquid. Okay. The same way as when we feel that gravity or acceleration due to gravity is effective, not exactly 9.8. It's something less than that. So we say that it is effective weight. Okay. The actual weight is less than the original weight. As we see in that the weight of an object is 60 kg on the earth, it will be 1/6 on the moon, right? So same as if you have something which having weight of 10 kg, when you will keep that in water, the water will exert a force upward, and then you will feel little bit less weight. Okay. So now move on to the further concept. Let's see what is it. So now it's time to define what is buoyant force. When an object is immersed in liquid, it experiences an upward force, as we know. This upward force is called buoyant force. The upward force acting on an object immersed in liquid is called the buoyant force. Due to the, okay, this is the extra one. Okay, so now it's clear when an object is immersed in a liquid, as we see. No, why I will draw the figure. We have already a figure. Okay, you have a bucket filled with water, right?
Yeah.
Now, whenever you go to the washroom, do this experiment. Fill the water. Okay. Then now take a jug, fill it with water. Now try to dip it little by little inside, and then see how this behaves.
I've tried it actually before when I was small. I tried to put the whole bucket inside, but it won't go inside. It'll come up.
Okay, so when you will press it now, when it will be around over here on the water surface, then it is tough to
put it down. Yeah.
Yeah. Okay, that's the maximum thrust you will feel, upward force you will feel. But once somehow you tilt it, okay, then put.
And
Then
water
again, if
does it.
again
Yeah.
when it will, say it's your time. You say your experience.
No, then the water ends into the bucket and then it starts sinking down.
Yes, sinking down. Sinking down. Okay, that's one thing. How that happens, that's the point to think.
Because you added the water, gave more weight to the bucket, and then it started sinking down.
That's one thing. The one catchword is weight. Right.
Yeah.
The one another catchword will be volume.
Yeah.
Another catchword will be density of density of liquid. These are catchwords. So now you try to put this mug inside. Okay, so it was over here that due to atmospheric pressure. Here is the atmospheric pressure on this surface. Okay, the pressure exerted by the environment or atmosphere is called atmosphere. So when these two surfaces comes in contact, they try to oppose the change. Okay,
Okay.
but when it is inside, you just dip it inside. Now you try to pull it upward. As we drag water from well or the bucket. So when you are dragging the same amount of water, taking out, suppose till inside the water, just realize, and outside the bucket, out of water. So where you feel more weight?
When you're lifting, when you're lifting a whole bucket.
No, only we are lifting the jug.
Yeah, then the jug, it will be more weight.
When?
When
Inside the
we're
liquid,
lifting it,
outside the
when
liquid.
we're lifting in the liquid.
So it will be more weight.
Yeah.
No. When we will be lifting, we will be experience a buoyant force from the water. Okay. So water will be lifting it as well, pushing it actually. And water upside will be pushing it downward. What about the water along this side? The net force will be 0, right?
Yeah.
But these two forces will be counteracting each other.
So when you're lifting up, it's less weight.
Until and unless it is inside the water.
Okay.
Okay. It will also depend on the height of this container bucket. Got the point?
Yeah.
There's also one thing. So it's bit clear.
Yes, sir.
Before that, now I have another example. See, this is a spring balance, okay? And this object weight 50 grams outside the water. As we are dipping it,
No, yes, sir.
it's your time. Actually, class is student centered, okay? Students are in center, teacher are just on the back side. So if you are having something to say, you are most welcome.
No, sir, I was just listening to you.
Okay, then tell me, what do we observe from this figure?
As soon as we're dipping the metal in the water, then the weight starts reducing.
Reducing, right?
Yeah.
So why this happens?
Um, uh,
Why this happens?
I'm not sure. Because
Yes, because
um,
classroom is always a student centered, okay?
yeah, I know, but
So you have to express yourself, try to express.
the water is reducing the weight of the object as soon as it's fully emerged.
So how many, so what, this is one of your observation.
Yeah,
Okay. What is your observation? Tell me again.
that the water is reducing the weight of the object as soon as it's fully immersed.
Water is reducing. How the spring balance works?
It 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 tells the weight of an object.
So how does it work? Have you used it?
No, but in school we have tried once. The teacher showed us.
Okay, just he or she showed you. Okay, you didn't touch that.
No.
Okay, that's not true thing. Okay, experiment is that unless until you won't touch the apparatus, you won't get the idea.
Hmm.
So first of all, how the spring balance works, you have to keep in mind. Let me try if I could. The design of spring balance is that you will find there will be a spring. Okay.
Yeah, then as soon as you put the object on the string, it starts pulling down.
There will be a lock
Hook.
hook. Okay. So maybe when we will apply the object, it will comes down. So maybe
Yeah.
here will be the scaling coinciding with 0, right? Whatever it is, somewhere there will be a scaling. Okay. So
Yeah.
when we apply the force, this spring get a stretch,
Huh.
right? So
Yeah.
if weight is more, the spring get more stretch will be more reading, right?
Yeah, I understood now why the weight is less.
Now tell me if you have got any idea.
Because as soon as it's immersed in the water, the upward motion force pulls the object up, which makes the spring go up and show a lesser weight.
Okay, so this is one observation. I agree with you. What is the another observation?
Another observation.
So actually picture tells a lot. Okay.
Yeah.
Picture tells a lot. What is other observation? That is one of the important concept. You may say that it is a theory.
Theory.
It's the theory. This figure says 2 theories. Okay.
It the
So tell me, have you heard the story about a thirsty crow who is dropping
yeah.
pebbles inside the empty
Yeah,
container, and then what is the
and
story?
the
Tell me.
water, the crow's thirsty. So there was one pot where very little water was there. So the crow decides to put many pebbles inside, so the water increases up.
Water increases up.
Like
Yeah. Go ahead.
the stone increases the weight, the increases the water and makes it up to
How a stone will increase the water? Do a stone generate water?
no no um
No, you said now what a stone generated the water or increased the water. You said like that, na?
it's filling up the space in the pot, which may, and since stone has more weight, it goes down to the bottom, whereas the water will reach to the top.
Mm-hmm. So why he crow may have put only one stone or two stone. So how crow got the idea that how many stones I have to keep into the container so we will get the water. How he got that idea?
He just kept on putting inside until he got the water.
Oh, so you think that he was not having wisdom? He was just doing it.
I'm not sure that's how he learned. He
So without wisdom, he must have not done that, na?
yeah.
So some physics he might be having, or what we say that law of nature he must be having.
Yeah.
So tell me a story. A story is not over. The story for a perspective of a philosopher, it's over there, okay. But for a scientist, it is still alive. Unless until I won't convince, nah, I won't let you go. Today class is just about like that. Just this,
Okay.
this chit chat, and I think we will be able to understand the important concepts. So tell me the story of crow, the clever crow.
The crow was thirsty and saw a pot. He started putting pebbles in the pot because he could not reach the water. So he put pebbles inside. And then the water started to rise up. And then he was able to drink the water.
Okay, so why water started to rise up?
Because the stone started to have equal weight to like weight to the water, like started to increase the weight of the water by
Weight
taking up
of the
this,
water. Weight of the
meaning
water.
like
Yeah.
it started to take up the space of the pot, which made the water rise up
Yes.
by taking up the space at the bottom.
Okay. Now you tell me in this figure. Now relate that story.
Oh, the water started to rise up when the object went inside.
Okay. So this is the concept actually. When we start talking, we cover a number of concepts. Okay. So this is one of the concepts.
Okay.
So what is the volume of this metallic cylinder? The same amount of water is being displaced.
So the object's weight is equal to the weight of the water.
Water displaced.
Yeah, immersed
Water
in the water.
displaced. Okay. So
Yeah.
in first figure, this water is at this level. Okay. In second figure, it just raised some by some amount. Okay. Because this much volume of this metal is now inside. The same amount of water is being displaced. Okay. It's from displaced from here. We merge it almost complete. So the weight of this block, okay, will be equal to the water displaced. So these two concept was my target for the day. Okay. So hope you have understood the concept, right?
Yeah.
Okay. So now it's time you just write the definition of this buoyant force.
So could you move it a little? No, nothing, sir.
I'm still thinking how that crow got that idea or concept.
So like you said, laws of nature, they learn all this on
Yes.
their own.
Yes.
Also finished.
Okay. So cause of buoyancy or buoyant force, basically there are two reasons of buoyancy. Okay. One is the volume of object immersed in the liquid, right? This
Yeah.
depends on the volume only. Either you are taking uh, iron, iron slab, okay, or brick of same volume, right?
Hmm.
Or a ice brick. Unless ice doesn't melt, okay, ice brick of the same volume. The water will be, the displaced water will be of the same amount, right?
Yeah.
It doesn't depend on the uh, nature of objects, only depend on the volume of object, right? The another
Yeah.
is density of liquid. This first concept is clear,
Yes, sir.
and another is the density of liquid, right? So how the density of liquid work? Do you
Density
have
of
any idea? What do we mean by density of liquid? We have water, okay, we have honey, okay. So whose
it-
density is large?
honey.
Honey, okay. So if you are dropping a pebble in water or in a
Yeah.
honey, how do you expect the motion of these objects?
Uh, for the water to sink more quickly than honey,
Okay,
because it will take time.
okay, because of density of liquid. Okay, so means that in water case, what will happen? Why such thing will happen? What
Because the
could be the
density is different. It's
okay?
less. Its density is less.
So just its density is low. That's why
Hmm.
you may develop some logic.
Okay.
Okay,
Hmm.
so what could be the reason? So you have to think in that way. If this happens, science is all about that. If you say that okay, is the daytime, so you must have to think why it's daytime. Is the night time. So why it is night time?
Because
If you go
because
ahead.
our side of the earth is facing to the not facing to the sun.
Uh, Same way, you have
Uh,
to generate some logic.
okay.
Okay, sometimes your logic may not be true. It happens with the early scientists as well. They given a lot of theory, but it was later discovered that were not true. But still, so
Yeah.
try to develop some scientific temper.
Okay.
So what could be the reason behind that?
Behind what, sir?
What is the density theory?
The
First, define what is density.
density is the different, different.
Are you
How do
aware
I
of
say
word
this?
density? Have you heard before?
Yeah.
Then go ahead. What do you mean by density?
Density is when it's related to the substance's mass. Uh,
When we say
it,
that some cities are densely populated, some cities are less or rare density populated. So how you will connect with this?
it'll be like it's the density means when the substance it's related to substance mass by volume.
That's good. Mass per unit volume, right? Density is that
Mass.
density is mass per unit volume. Mass per unit volume. Per unit volume.
Yeah.
Per unit volume. Now see how this definition will strengthen our concept. What about the mass per unit volume in water and mass per unit volume in honey? How this will be changing?
Water has less mass than honey.
Mass per unit volume.
Per unit volume,
Yeah.
water is less than honey.
Okay. So to density, we give it a symbol. Okay. Density. Now see. Density, we give it a symbol rho. Okay. This is mass per unit volume. Right?
Yeah.
So what will be the volume? Volume will be mass divided by rho. Clear?
Okay. Yeah.
So what is relation between if the mass is fixed 1 kg mass 1 kg or 1 kg honey? So what is relation between volume and
No,
density?
1 liter or like 1
Yeah,
ml.
yeah. So that's why I was making face. Okay. So we see that volume is inversely proportional to density, right?
Yeah.
It means that V is more, then rho is less.
Yeah.
Okay, if V is less, rho is more. Clear? Now
Yeah.
now you get some. Did you get any idea here?
That
Its density is less.
yeah, the density is less.
Its
So that
density
means
is
the volume is small.
volume is small,
More. Yeah.
right? So volume displaced will be small, right? Okay. So here the volume displacement will be low, more.
Yeah.
So here it will go without much, what can I say, upthrust.
Yeah.
Here it will be a little more upthrust.
Okay.
So now I have a question to you. It is basically related with the volume. Okay. So why ice float on the water? Why do ice float on the water surface? Why not it go down?
Because of the upward force pushing us up.
No, that's the play of density. If we
Oh.
have two type of liquid, okay. This is liquid, that's water. Okay, now what you do, you just take a balloon, fill it with air and put over here. So what it will do?
It'll float.
Okay, now the same balloon you filled with some liquid who has density more than water. Fill this balloon with sands or pebbles. What will happen?
It will sink.
Okay, so this is because of density, right?
Yeah.
So ice density is less than the water density. Or it is reverse. Whose density is more, ice density or water density?
The water density.
Water density is more than ice density.
Yeah.
Do you feel it?
Yeah.
Seriously?
Ice you're talking about, right, sir?
Huh?
Ice, right?
I didn't get.
Ice. Talking about
Yeah.
ice. Yeah, it will float.
Ice density is more than water density.
No, water density is more than ice.
Ice density. But we see that ice is somehow in the liquid form, solid form, but water in as the liquid form. So liquid density is more or ice density?
Liquid density is more.
Liquid density is more. Oh, okay. So this discussion is over here. So volume and density have reciprocal relation, mass per unit volume. You will study this more in higher classes, okay?
Okay.
So now we have, actually we discussed already, okay, we have these two beakers. The density of water is more than the no, ground nut. I remove part one, okay, so we will read this, the second one. The density of glycerine is higher than that of water. So glycerine will exert more buoyant force on an object immersed in it than water. So density is more. So what will be the buoyant force will be more. The density of glycerine is higher than that water. So glycerine with a more buoyant force. So now that force is somehow proportional to mass into acceleration, right?
Yes.
Mass is what? Mass is rho into v into acceleration, right? So here we have replaced it with rho. Volume of water or volume of some object, it will remain fixed. Okay, suppose I'm dropping this amount of objects in two different type of liquids, in this and in this. So volume of object is fixed, okay? What is different? The liquid, the density of liquid is different, right? So we say that this volume is constant. And we are putting it with a constant acceleration as well. We are not changing the acceleration. We are putting it slowly. Okay. Okay. So now force depends on density only, means that combination of liquids or nature of liquids. So if density is more, the exert force will be more. So it is good to understand the idea.
Yeah.
Okay. So this could be the some scientific reason. Okay. Actually, the true derivation of these buoyancy force and all you will encounter in class 11th, sorry, in 12. If you study the science, there is detailed chapter, right? So just I am giving you some more than required knowledge as well. You may be understanding something. If you are not getting, then let me ask. Okay.
Okay.
I'm trying to make it as simple as, because I'm trying to bring more pictures and all, because when you see the picture, a picture comes in our mind.
Yeah.
Right. What we see, we understand. So this was the one of the reason, and what we studied, it is a summary of our class. This is one is the Archimedes principle, which what is said when an object wholly or partially immersed in a liquid, it experiences a buoyant force or upward thrust, which is equal to the weight of the liquid displaced by the objects. In other words, buoyant force upward thrust on an object is equal to weight of the liquid displaced. Right?
Yeah.
We discussed all it. Now is time just to write down the definition.
Okay.
Okay, do it. We have everything for you today.
So finished.
Okay, so let me give you some explanation of these statements. Okay. I will write in front of you. Actually, it's not the part of your syllabus, but as you are the intelligent student, I have to give you some extra knowledge. Okay. So what is weight? It is m into g, right?
Hmm.
This is weight. What is mass over here? Rho into v.
Yeah.
Rho is rho. What is volume? The volume of any object is just the area
Into height.
to height, right? Who is entering in the class? So area, this is A and height is H, right? So rho
Yeah.
is as A into H. So
Okay.
just replace it. This will be rho V
Into
G. Okay, now we will replace the V with A into H.
into
Rho A into H times G. Rho GH, rho GH. This is A, rho A, this rho VH. So somehow if we encounter some numericals, okay, we have to so. So, but in your cases, this definition is not included. But for the extra knowledge, you keep in the mind. Okay. So now I will try to give you one numerical. When when an aluminum object is immersed in water, it displaces water. It displaces 5 kg of water. How much buoyant force acting on the aluminum in Newton if G is this? Can you do it?
Okay.
What happened?
1 minute, sir.
Okay.
Yes, I got the answer.
How much?
50 Newton.
Okay, that's good. So whatever you learned today is clear. Any doubt?
No, sir, I don't have doubt.
Okay, then we have to say I'm sorry because there was some network issue. Okay,
Yeah.
so I
Actually,
couldn't.
I have one doubt about that bucket and what that jug example.
Mhm.
I understood how the upward motion is like the thrust is there. Uh, and the same thing also happens when you put the jug upside down, whether it will, if you put it at the bottom, it still comes up. That's the same
Actually,
example.
actually, if you are putting a bucket, sorry, jug inside the bucket, so what is the volume of bucket? Sorry, what is the volume of jug? Okay, so you have to displace that much amount of water. If you successfully displace such amount of water, then jug will go inside.
Yeah,
Got the point?
and so when you put the jug upside down, so the water does not enter into the jug.
Upside down means
Means if you put the jug upside down and put it in the big bucket, and try to push it down, the water does not enter in the bucket.
upside down means you are saying like this.
Yeah,
Okay, so water doesn't enter in.
yeah. Until you tilt it, then the water enters.
You do the same experiment with transparent jug. Okay.
Okay.
So if you are putting like that, the water will just go inside. I don't think there will be such issue.
No,
But
I tried it once. And it,
no, you get a transparent, get a water bottle, cut it, okay, and then you
mm,
put. You will see that it will different issue. If you are putting like that, then you have to displace this much amount of volume. So in
oh,
displacing that amount of volume, you have to apply the force. Okay,
mm,
but
okay.
but but you are putting like that. Just open the nib or that cork, this knob, or just put it
Yeah.
inside. Then water will start entering. Okay, if you cut the upper part, okay, so it will get some air, so it will be easily go down.
Okay.
Okay, so do the experiment with transparent tank.
Okay,
Okay.
sir. Okay, thank you.